TI unique times only that transaction. This times is not. So unique fixed timestamp which so transaction TI and timestamp and its timestamp. Associated with every transaction and it is denoted by TSTI. Next, timestamp is assigned by the database system before the transaction TI start execution. Suppose I want to execute a transaction T1 which transfer $50 account A to account B. So that transaction first assign a time to the database system and then the execution of the transaction means read A and whatever the next operation is start its execution. But before that, the timestamp is assigned to the database system to that particular transaction. Now, each transaction is into the timestamp. It enters the system. Whenever the transaction enters in the system, the timestamp is given to the transaction. If all transactions TI has a timestamp TSTI, if a transaction TI has, which is all the one, no transaction in TJ, then TSTI is always less than TSTJ. Then TI is always less than TSTJ. Again, read is issued a timestamp when it enters the system. In this case, if there is an old transaction TI and a new transaction TJ enters with the TSTJ, then TSTI is always less than TSTJ. Means this is the old and this is the new. So old timestamp is always less than new timestamp. Okay. How to assign this timestamp? How to assign this timestamp? So there are two methods to assign the timestamp. One method is to use the value of system clock as a timestamp. When the transaction is enters in the system, whatever the system clock at that time, that is assigned. Means suppose the transaction TI enters in the system, today is 10/11/2020 at 9:39 and some 25 seconds. Also we can say this way. So that value, whatever system clock at that time with the date fixed time, that is assigned as a TSTI. So if a new transaction TJ enters after it 10, a new timestamp 10/11/2020 9. Suppose it enters in the system at 31:25:00. So which is smaller? In that case, the old one TSTI is always less than TJ. TSTI is always less than TSTJ. Is it clear to everyone? See another method, that is use logical counter. That increment after a new timestamp is assigned. Example, suppose logical counter start with 1, 2, 3, 4 and TI when it enters into the system, the counter is now at 25. After that, the transaction enters TJ, then its timestamp suppose whatever the counter, it is assigned to the next counter or logical counter value. So in that case, also TSTI is less than TSTJ. So any one of this method is used, either system clock or logical is used. Is it clear to everyone what is meant by timestamp? So it is not It is only what is by timestamp. Protocol rules we are going to see afterwards. Yes or no? Is it clear? For each transaction, the system assigns a timestamp value which is denoted by TSTI. It is yes or no? Are you? So this way, another thing is that when a transaction, old transaction TSTI is there and another new transaction in the system, then in that case TSTI is TJ. And there are two methods to implement this scheme. Either use the system clock, use the logical counter. It depends upon the database, which method is used. Now, another thing with the timestamp ordering protocol, of the transaction determines the seriality order. Means if TSTI is less than TSTJ, then what we ensure that TSTI comes before TJ. So if we execute serially, which is executed first? In this case, first TI is executed and then TJ. In which transaction TI appears before transaction TJ, consider a schedule in TI. So in this case, first TI is executed and then TJ is executed. Serial order. If it is a concurrent, then we need to check whether it executes properly or not. It is a serial and TS is less than TSTJ. It is sure that transaction TI execute first and then transaction TJ execute. Now this one. In order to assure such behavior, the protocol maintains for each data item Q two values. The first one is W timestamp Q and the R timestamp. What is W timestamp Q? Timestamp Q is the largest timestamp of any transaction that executed write Q successfully. It is the largest timestamp of any transaction that executed write Q successfully. If transaction TI execute write Q successfully without any error, if transaction TI execute write Q successfully, then what is W timestamp? W time of data item Q is equal to TSTI. It is the timestamp of transaction which execute write Q successfully. So who execute write Q successfully? Transaction TI execute write Q successfully. So W timestamp is the largest timestamp of any transaction that executed write Q successfully. And that's why W is equal to TI. Same for R timestamp is the largest timestamp of any transaction that executed read Q successfully. So if the transaction TJ executes read Q successfully, read operation Q successfully. Successful reading is important. Why? Because reading or writing. If the instructions are conflicting with each other, it may create the problem. So if TJ execute read Q successfully, then what is R timestamp of Q? It is TSTJ. Is it clear to everyone what is the timestamp and what is timestamp? Time transaction. Okay. Now read times of are conflict and right operation means what? Anyone? When we two read and write operations are conflicting, when they are the same data item and any one of the operation is the right operation. If any one of the operation right operation, then we conflicting mean Q and Q. If transaction it is T1, it is T2, or it is Ti and this is Tj, and though both performing read Q, then it is not conflicting. It is not conflicting. Why? Because only reading is performed there. But it is performing read Q, write Q, then it is conflicting. That part will be in the previous lecture. Okay. Next, write Q and read Q. It is also conflicting. And write Q also conflict. So in that case, when we say read and write operations are conflicting when they are operating on the same data item, when any one of these instruction is the right instruction, then we are conflicting. So while we consider this protocol, we consider this thing. Suppose that, am I audible now in proper? My saying what is breaking? Am I audible in proper way? Okay, so the rule. Suppose transaction Ti is a read key operation. Suppose the transaction Ti issues a read key operation. Then if Ti is less than W timestamp, if TSTI is less than W timestamp, then Ti needs to read a value of Q. Then C, Ti needs to read a value of Q that was already overwritten. Means read comes before write. Read comes before write. It try to read a value before write operation. It try to read a value before write operation. Okay. In that case, read comes before write, and that's why the read operation is rejected. In that case, the is rejected and the transaction Ti is rolled back. About first, if TSTI is greater than W times greater than or equal to W times Q, then read operation is executed. Means what? This TSTI is greater than W times. Means read comes after write. First, a write operation is performed on Q and then it is read by another transaction Ti. Then read operation comes right, it is executed, and the new timestamp is R timestamp, which is maximum of previous R timestamp here. Whatever the maximum, it is applied. Have you understood? See here, and again I am explaining. If TSTR is less than W timestamp Q, means the read operation comes after the write, and that's why this operation is rejected and the transaction is rolled back. And if TS is greater than or equal to W timestamp, W timestamp means read operation comes after the write operation, then this read operation is executed successfully. Now the next one. If transaction is issuing a write operation, now the next one is write operation. If TSTI is than R, if TSTI is less than R timestamp, then the value that TI is producing needed previously. TSTI is less than R timestamp Q, then the value of that TI is going to write is needed previously. Means what? Means this value of Q is required by TJ, but it is written after it. Have you understood? If TSTI is less than R timestamp Q, then the value of Q that TI is going to produce, that value of Q that TI is going is required previously. And the system assumes that the value would never be produced and the write operation is rejected and rolled back. The write operation is rejected and TI is rolled back. Another case, if TSI is less than W timestamp, if TSI is less than W timestamp, then TI is tried to write a value that is already written. TI is tried to write a value which is already written by another transaction. What we call it as a option, or we call it as a blind write. It is a blind write. TI is tried to write a value which is already written by another transaction. So this write is known as absolute write or blind write. And in that case, the write operation is rejected and the transaction is rolled back. And the third, otherwise, if TSTI is greater than or equal to W timestamp, otherwise the write operation is executed. And W timestamp is set to TSTI. So in this way, read and write operation is performed in timestamp based protocol. Now see, another one protocol is, or the modification to this timestamp ordering protocol is the Thomas Wright rule. One example is before that. Suppose we want to do transaction. The first one that read the value T25, which read the value of A and B and display A plus B. And the transaction T26 transfer $50 from account B to account A. So in that case, it will execute in this way in current. Now TS25 is less than TS226. Why? Because it comes before TS226 in the system. And that's why here two and A. So here what it's then display which is so and execute as a concurrent control or concurrent execution. Okay. So Thomas Wright rule. In the previous we had what is the second of write operation if TSTI is less than W times. Then Ti is attempting to write a value which is already written by another transaction. So what we call it absolute write or blind write. So in that case, modification to this is the Thomas Wright rule. These two TST27 and TST28. So initially TST7 is that TST28 it comes before this one, and that's why it is less. Now it starts with the read operation. So it's executed properly. So what is our timestamp here? Our timestamp is TST27 as it is executed. Before that, there may be instruction. Some part is given here.